Welcome back to the channel. As you should know by now, I'm no coding wizard when it comes to model railroad automation, or any other coding for that matter of fact. However, inspired by my success of adapting others' work to my own and building automated switching control boards, see the link for that video here, I've decided to try my hand at Aurdino coding once again. Here's the issue. These hidden tracks on the back side of the layout were always intended for allowing two trains to run on the front side of the layout from opposite directions. The passing siding works as intended, but I need a reliable way to know which siding the hidden train is on and possibly which train is set in which direction should both be stored back there. Okay, so let's start with the super simple. The components I'll need for this demo is my Arduino Uno, an IR detector with digital output, a red LED, and some DuPont connectors. First, we hook up the orange jumper to the output pin, and then the white to the ground and the black to the 5-volt pin on the IR detector. The two jumpers will go into the ground and the 5-volt output on the Arduino, which are conveniently located right next to each other. Then the digital output orange jumper goes into digital pin number 2. The short leg of the LED is ground, so we'll put that into the other ground pin on the opposite side of the Arduino, and the longer leg into pin 11. This will make a simple circuit to test the code. And now it's time for that simple code to see if we can get this thing running. And when I say simple, I mean simple. I'm not declaring any integers. I'm just going to use the void setup to set pin 2 as input and pin 11 as output, and then the obligatory serial begin to 9600 baud. On to the loop. One simple if-else statement. If the sensor is detecting a reflection, we set the LED to high. Else, we turn the LED off by setting the pin to low. Back to my little tabletop demo setup. The goal for this first attempt is to have the IR detector turn the LED on when a rail car passes in front of it. Passing my finger in front of the sensor, we can see both the onboard LED and the red light on the Arduino light up. Okay, so the sensor and the LED are working. Now let's see if we can work up a simple mock-up. I tape the sensors horizontally, even though most everyone else drills out some track and places the sensors in between the rails. But my ultimate plans are to install these into a railroad building. I found this signal box on Colts 3D, and it's specifically designed to hold this type of IR sensor. The problem is after printing, curing, and painting, the sensor doesn't fit up from the bottom. The issues are the building footers are too close. So I just cut them off with a hobby knife, and voila. Now we can get the sensor, IR, and receiver LEDs oriented correctly. We just need to bend them 90 degrees, and there we have it. So because I'm setting these up to be next to the tracks and read up the sides of the train, I shouldn't need to put white cards or paint a white strip on the bottom of all my engines and rolling stock. All right, let's test this out. First with a black car. This should be the hardest to read, so why not? Hey, look at that. It reads okay. But I think the delay is causing some of the issues with the intermittence. So I removed that line of code, added a boxcar and a tank car to see what happens. And there we go, a simple code and setup to test the concept and to teach this old dog a new trick. I hope you enjoyed this quick little tutorial. Look forward to the second set where I get a little more complicated so I can actually have this function on the layout. Anyway, I hope you enjoyed it, and if you did, consider a like and subscribe, and as always, happy railroading.